Welcome to another fantastic edition of Common Algebra. This video is for Chapter 11, Section 7, Multiplying and Dividing Radical Expressions. So if you think back to Chapter 9, we learned a lot about multiplying and dividing polynomials. That's where you learned foiling and those types of skills. And now we have learned how to multiply and divide radicals. We learned how to rationalize the denominator. So we're going to take our polynomial skills and our radical skills, and we're going to put them together, and we're going to multiply and divide radical expressions. Now, a lot of it is very, very similar. You do follow the same exact rules you did when you're multiplying polynomials. The foiling is the same, distribution is the same. But after you're done multiplying with all these radicals, you do simplify them like we already learned, and then we combine the like terms just like we always have. So that's about it for an explanation. Let's look at some examples. In example 1, we see we have a binomial times another binomial. So the strategy we will use is to FOIL this. So first times first, square root 7 times square root 3 is square root 21. I'll put the arrows in if that's helpful. And then the outer product is negative 6 times square root 7, which is just that, negative 6 square root 7. Remember, you can only multiply numbers if they're both under a radical. The inner product, square root 2 times square root 3, is square root 6. And the last times the last, negative 6 times square root 2 is just that, negative 6 square root 2. So now I'm scanning through and I'm looking to do any simplifying. 21 is just 7 times 3, so that can't be simplified, and 7, 6, none of these can be simplified. So now let's look and see if we have any like terms. Well, we have a square root 21, a square root 7, square root 6, and square root 2. There aren't any like terms. We're done. This is a 4-part answer, and we can't simplify it any further. So let's move on to example 2. Again, we have a binomial times a binomial, so we know it's foiling. First times first, square root 5 times square root 5 is square root 25. Ooh, I hope you're seeing some simplifying there. Square root 5 times a positive 7 is just that, 7 square root 5. The inner product is negative 7 square root 5. And the last times the last, negative 7 times positive 7 is negative 49. And here we do have some simplifying to do. The square root of 25 is 5. And look what happens here. A positive and a negative add to 0. So I'm left with 5 minus 49. And that leaves me with negative 44. So all that foiling just came down to a single answer, and all this foiling gave us a 4-part answer, and we can get anything in between. In example 3, I can see that I have a binomial squared. And since I'm very visual, I do better if I write this out as this binomial times itself. Otherwise, you are in danger of not seeing the foiling. So I'm going to be careful and do it this way. Again, I'll draw the arrows in if that's helpful. Square root 3 times square root 3 is square root 9. Can I just write that as 3? The outer product, square root 3 times negative square root 2 is negative square root 6. The inner product is also negative square root 6. And let's be careful here with this negative square root 2 times negative square root 2. Let's look at that a little closely. What you really have is a negative 1 square root 2 times another negative 1 square root 2. The negative times the negative is a positive. The square root of 2 times square root of 2 is the square root of 4. So that leaves us with a plus 4. So make sure you ask if that's not clear. And now we can combine some like terms. We have 3 plus 2 is 5. And a negative 1 square root 6 and another negative 1 square root 6 is a negative 2 square root 6. So this time we ended up with a binomial as our answer. All right, I just want to take a minute and remind you of something that you already know. We learned in another section that if we have a square root in the denominator, you can't divide by an irrational number. So we learned that we had to multiply multiply that denominator over itself to get a new fraction with no square root in the denominator. And this was called rationalizing. Well, now in this section, we have a denominator that has a square root in it, but it's a binomial. So this requires a little different skill. Our problems are going to look like here in example 4, where we don't just have a plain old square root 7, we have square root 7 minus 2, and this is a number. I'm going to put parentheses around it to emphasize that you can't just multiply by square root 7 over square root 7. So we have to think back to something that we learned. We talked about this in the factoring chapter and in the polynomial chapter in chapter 9. Do you remember what a conjugate is? And if you remember that, it's the same binomial except with a different sign. The conjugate of a minus b is a plus b. So if I asked you what's the conjugate of 7 plus square root 3, you would say it's 7 minus square root 3. So note here, when the denominator of a radical expression is a binomial, you rationalize it by multiplying the numerator and denominator by the conjugate of the denominator. So let me just kind of show you a little bit of a why thing. If you saw this and you thought, well, I'm going to do it the same way I did it before, and I'm going to multiply by square root 7 over square root 7, and that's going to work for me. Okay, don't write this down, but let's try it. So that would give me a numerator as 5 square root 7, and here I would have to distribute this square root 7. Okay, it's looking good when I take the square root 7 times square root 7, and I get 7, but then look what happens here. Negative 2 times square root 7 is just that. So we got rid of one radical, but we ended up with another one. So I just wanted to show you the why part, why we need to use a conjugate. So let's do example 4 now using a conjugate, and I think you'll see what's special about multiplying by a conjugate and why it gets rid of the square root in the denominator. Again, I'm going to put this binomial, all these binomials in parentheses. Okay, conjugate of square root 7 minus 2 is square root 7 plus 2. And I put them in parentheses because that visually helps me see the multiplying better. So in the numerator, we distribute the 5, and we get 5 square root 7 plus 10. And we FOIL the bottom. And I think you'll recognize this thinking back to our FOILing chapter. Square root 7 times square root 7 is 7. Square root 7 times positive 2 is plus 2 square root 7. Negative 2 times square root 7 is negative square root 7. And negative 2 times positive 2 is negative 4. And look what happens when you multiply conjugates. The middle terms add to 0. So this denominator can simplify down to 7 minus 4. And you'll notice there's no square roots in the denominator. So we're left with 5 square root 7 plus 10 all over 3. And I'm just going to give you warning, this two-part numerator and this one-part denominator can only be reduced if you can reduce all three of them. This is what I call an all or nothing. And you can't just reduce, like if this was a 2, you couldn't just reduce the 10 and the 2 because the 5 doesn't have a 2. So my warning here, don't reduce these three pieces unless it's all of them. All right, one more example. And again, we notice right away in our denominator here, we have a binomial. So we know this is the conjugate method of rationalizing the denominator. The conjugate is 5 plus square root 3 is 5 minus square root 3. So we put the conjugate over itself. This one is particularly a lot of work because to do this multiplying, we have to FOIL the numerator and FOIL the denominator. So first times first is 20. If you want the arrows, I'll draw them in. The outer product is negative 4 square root 3. The inner product is 5 square root 3, and the last times the last is, I guess I'll just write it out, negative square root 9. And obviously we have a lot of simplifying to do there. The denominator, again foiling, 5 times 5 is 25. The outer product is negative 5, negative 5 square root 3. The inner product, see why I need to look at it? I'm that visual, is 5 square root 3. And the last times the last is minus square root 9. Okay, now let's simplify both the numerator and the denominator separately from one another. So this square root 9 is 3, and 20 minus 3 is 17. And these two are alike terms. A negative 4 square root 3 plus 5 of them is 1 left. So this is 17 plus square root of 3 for the numerator. Now looking here in the denominator, these two add to 0, so they're gone. This is a minus 3, and so I end up with 25, take away 3, which is 22. So I'm just pausing for a moment to see if there's any simplifying. This 3 can't be simplified, and remember, it's all or nothing to reduce, so this is my final answer. All right, now you have the knowledge you need to do section 7, so have a radically awesome time with that.